and welcome to the fourth video in this series of tutorials on fractions. In the previous tutorial, I talked about multiplying and dividing fractions, and in this tutorial, I'll be talking about adding and subtracting fractions. Now, when we do arithmetic with whole numbers or integers, as we all know, adding and subtracting is significantly simpler than multiplying and dividing. With fractions, it's the other way around. Multiplying and dividing fractions is more straightforward than adding and dividing fractions. Let's see why that's the case. And we'll start with a simple example. So fractions continued. This is the fourth tutorial. And let's start with adding fractions. And let's consider a very simple example. Let's imagine we want to add 1/2 and 1/3. And let's actually look at that in terms of our favourite metaphor for fractions, which is birthday cake. So let's imagine that there was a party, 2 cakes were baked, and they were identical cakes. Guests enjoyed them. In one case, half of the cake is left over, and in the second case, 1/3 of the cake is left over. And the question is, how much total cake as a fraction of a whole cake does the host have left over, perhaps to enjoy themselves secretly once all the guests have left? Now, on the face of it, this is actually quite a hard question, because the key point here is that when you're looking at different fractions like 1/2 and 1/3, you almost feel like you're looking at an apple and a pear. These two objects are different, and how can you possibly add them together? And the key to this is the following, that you need to rewrite each of these fractions in such a way that you're dealing with a common object, a common currency, if you will. And to see that with the example of the cake here, if we divide each of these cakes into sixths, then this half a cake is equivalent to 3 slices, each slice being 1/6. And this third of a cake is equivalent to 2 slices, where each slice is 1/6. And so we could write this then as a half as 1, 2, 3 lots of a sixth, and then a third as 2 lots of a sixth. In other words, we would be adding 3 sixths and 2 sixths. And the total number of sixths that we're adding is 3 plus 2. 3 sixths plus 2 sixths is 5 sixths. And that's the answer. So a half plus a third is 5 sixths. And using this metaphor of the cake, what we've shown is that the technique for adding fractions is to identify a denominator, in this case 6, with which you can rewrite both of the fractions. So let's do another example. Let's imagine that we are needing to add, 2/3 and 1/4. Now what I need to do is to rewrite both of these fractions in terms of a common unit, a common denominator. And I can tell you the answer ahead of time. It's going to be a 12th. And one way to think about that is the following. Remember, in I think it was in the second tutorial as an aside, we talked about the fact that you can always write 1 as any number you like divided by itself. So 1 can be written as 3/3, or you could write 1 as 4/4, and so on and so forth. And that's actually one way to think about this. We can multiply 2/3 by 1, but we're going to write 1 as 4/4. And then this fraction 1/4, we're also going to multiply that by 1, but we're going to choose 1 in the form 3/3. And you can see what I've done here. I've chosen the way of writing 1 that sneaks in this denominator into this fraction, and it sneaks in this denominator into this fraction. So for the first fraction, I've written 1 as 4/4, and in the second fraction, I've written 1 as 3/3. And you can see what's going to happen when we do this fraction multiplication in each case. On the bottom, I'm going to get the same denominator, 12. And this really is the key to adding fractions. So let's use our knowledge of multiplying fractions to do these little sums here. So I have 2 times 4 divided by 3 times 4. And then for this one here, I have 1 times 3 divided by 4 times 3. So I'm just using the technique we learned in the last tutorial on multiplying fractions to do each of these manipulations. And looking at this first one then, I have 8 divided by 12. And in the second one, I have 3 divided by 12. And so my original sum has come down to 8/12 plus 3/12. And because the denominator is the same, this is very easy now to just add. 8 lots of something plus 3 lots of something is 11 lots of that something. The something in this case being 12ths. So 8/12 plus 3/12 is 11/12. And that is the answer to this sum. Let's do another example. I'm just making these up as I go. So let's imagine we have to add 5/6, and I'll just make up something. Let's do 2/5. So I'll take that first fraction and I'm going to multiply it by 1, but I'm going to choose to write 1 as 5/5. And I'm sneaking in this denominator here, you see, by writing 1 as 5/5. And then the second fraction, 2/5, I'm going to multiply by 1, but I'm going to write 1 as 6/6. Okay? And in that way, again, you can see that now these two denominators, once I've multiplied the fractions, are going to be the same. So let's do it step by step. So we're multiplying fractions here, 5 times 5 over 6 times 5. I'm multiplying fractions here, 2 times 6 divided by 5 times 6. Do the products here, so that's 25 over 30 plus 12 divided by 30. I have the same denominator now, so I have 25 30ths plus 12 30ths, and that will be 25 plus 12 is 37 30ths, and that will be the answer to the fraction addition. So this really is the method of adding fractions. Now, I should just say that in practice, one can do it a little bit faster than this very kind of pedagogical, clear technique I'm using of multiplying by 1, but choosing 1 as something over something in such a way that I get the same denominators. A slicker way of doing this is something called cross multiplication, and I recommend this method. It's very easy to use. Excuse me, paper slipping there. Cross multiplication. And we'll just demonstrate it. Perhaps we'll just do this we'll do these two examples by this method of cross multiplication. It's a little bit faster, as you'll see. So here, the idea is to take this number upstairs to here, and I'm going to write 2 times 4. I'm going to write plus, and then I'm going to take this number up to here and write 3 times 1, and put the whole thing over 3 times 4. What I've essentially done is force both of these objects to be over the same denominator, and I've sort of cut to the chase about what to expect in the numerator. 2 times 4 is 8, plus 3 times 1 is 11 in total, divided by 3 times 4 is 12. And you see I get to the answer in a few fewer steps than in this very careful method. Let's just do the other example. 5/6 plus 2/5. Again, I'm going to take this upstairs and write 5 times 5, and then I'm going to take this upstairs and write 6 times 2 all over the product of these two denominators, 6 times 5. And I have 25 plus 12, which is 37, divided by 6 times 5 is 30. And that gives us, of course, the same answer that we got before. So this cross multiplication method is a faster way to get to the answer, but it's really based on the ideas that we've talked about above. I think I'll end this tutorial here, and we'll just do the next tutorial on subtracting fractions very quickly to show that it's really the same method, except that one will be replacing the plus with a minus. So I hope that's been very helpful, and I'll see you for the next tutorial.